Problem 2.12 is also a numerical problem concerning a particle in a one-dimensional box. So a particle of mass 9.1 into 10 to the negative 28 gram, which would be 9.1 times 10 to the negative 31 kilogram, in a certain one-dimensional box goes from n is equal to 5 to n is equal to 2 level. The mass definitely looks very similar to the mass of an electron, but we don't know what the particle is. It doesn't really matter. We just care about the mass of the particle anyway. So when it transitions from n equals 5 to n equals 2 quantum level, it emits a photon of frequency 6 times 10 to the power 14 per second. We are asked to find the length of the box. So we know the frequency of the photon that's emitted, right? When we know the frequency, we can compute the energy related to this transition. That would be h nu. So joule second times 6 into 10 to the 14 second. This gets cancelled, and we can just multiply this. 6.626 times 6 is going to be 39.756 times 10 to the power negative 20 joule. Or I can write it as 3.976 into 10 to the negative, approximately 10 to the negative 19 joule. Now, in this question, we are asked to find the length of the box, right? Now, the energy transition for a particle in a box is given by 5 square times 8 square over 8m out square minus 2 square, 8 square over 8m out square. So this is going to be 25, and this is going to be 4. So 25 minus 4 is 21, 8 square over 8m all square. So we know this energy is 3.976 into 10 to the negative 19 joule. 626. Yes, so this is what we need to find out. So I'm going to do a cancellation of units here. Just for the units, we have joule second squared over kg here, and joule is nothing but kg meter squared over second squared. We can see that it leaves us with a unit of meter squared. So length squared should have a unit of meter squared, so that makes perfect sense. Now let's go ahead and compute the value on the right-hand side. So I'm going to get 3.1852 times 10 to the power. I'm going to put together all the powers of 10. Meters squared. So this is what I get. Now, if I were to take the square root of this, it would give me 3.1852, and the root would be 1.785 approximately times 10 to the power negative 9 meters. So this is nothing but a nanometer. So I can say the length is approximately going to be 1.8 none majors.